So next we move for AI-based risk assessment system for Prozoro. Please welcome.
Hi all. Main idea of Prozoro, everyone will see everything. All data inside the procurement system are open, well organized in JSON schemas. But when a lot of money comes in some places with the government, there are always a lot of corruption. So we, in this particular task, we want to answer the question, is it possible to create an AI-based model that will find corruption risk tenders as well as 10 years experts? What we get, what we have for this? In mind, the question, quick answer for this project, yes, it's possible. At least with 86% of accuracy. How we do this? We have the data. We show experts pairs of tenders with a lot of meta information of these tenders and ask them which of the tender of this pair are more risky. The experts answer for us more than 3,000 pairs. Then we try to set up these answers in one rank. We start with good known Elo score, which used in chess grandmasters, but they give us only 78% of accuracy. Then we add some random noise and swap techniques, which we get from well-known quicksort algorithm, and finally get accuracy at least 98 and 8. Now we set up already labeled data. Is it possible to set up any tenders on the same algorithm? We start with simple linear model based on a probability of each risk. With condition probability, we get only 62% of accuracy. It's obviously not enough because if you compare single pair and you have only to answer left or right, so obviously any random generator will give you at least 50%. If we implement bias theorem, we get a little bit more, at least about 67%. Obviously, it's still not enough. We need to go deeper.
So what we did next is, once we got this line of tenders, we made an assumption that let's assume 10% of those tenders are the most corrupted ones. And Igor built a model based on LvDS, which was able to predict if the tender is looks like the most corrupted one with 68% accuracy. Later, Mikola, who is not here right now because he had to go home, he used the same ELO ranking, but he used logistic regression, which showed similar results. But we started to think if maybe we can switch from marking a tender as corrupted or not corrupted one, because we don't have real labels for that, to mimicking the behavior of the real expert who is looking at the pair and choosing if it's which one is the most corrupted one. So Mikola built a logistic regression to mimic the model of an expert. The model saw 100 features from 2 tenders and predicted if the left one or the right one is the one who is more corrupted. That model achieved 78% accuracy, and we thought maybe we can do more. So we tried neural networks with a couple layers, and that showed a bit better results, but then we tried XGBoost with random grid search, and we found the parameter list which gave us 86% accuracy, choosing which tender is more corrupted from the other one. What to do next? First, do more feature engineering and get more data from data experts. Because right now there are a lot more features than they show us. Maybe we can squeeze that amount and predict better. We found one thing which is called relevant vector machines. We would like to try it in the future. And investigate more landing-to-rank mechanics and maybe put them inside. Right now we ran our best model on the dataset, selected top 30 corrupted tenders, and the last 30 corrupted tenders gave them to experts and waiting for their response. But in the top 30 ones, we found a tender which doubled the price of the money government could pay, and in the lowest 30 tenders, there was a tender which actually let the government save more than 50% of their money. So we hope we can work on this further and maybe move it to the whole 2 million dataset of Prozor.